In the previous video, we talked about the basic C data types, and we talk about literals and we saw literals and constant as part 1. This is like a continuation of that video. Yeah, I just want to clarify what constant really are. So in that video, I said when creating your program, right, you have two types of data. The data which is known before running your program, and this type of data is referred to as literals or constant, and they don't change throughout your program. And I also talk about dynamic data, which is data that change each time you run your program. We saw like the 4 literal types you can find in the C programming language. We saw the integer literals, we saw the characters, the string, and the floating type. Okay, in this video I will explain to you why constants are considered as literal. 20 here is an integer literal. It is also referred to as a constant. Okay, so why do I consider this value 20 as a constant? Now, and I said A is a variable, right? We have not yet talked about variables, so the next video will be about variables only. Why do I consider 20 as a constant? From the definition of constant which I gave, I said a constant is a value that will not change. Okay, each time you run this program, right, this value will never change. There is no way this 20 here will change. Okay, but on this other line, right, we can change this 20 into another value, which thanks to a variable. So a variable is like a container that holds in data. Okay, so we can change this 20. We can assign A to be, let's say, 40, right? So that means we have changed the value. There is a keyword in the C dictionary that is called const. When I declare a variable using this keyword const int b equals to 20. Now most people are confused, right? Okay, let me explain this line of code. 20 is a constant, b is a constant. Okay, 20 is actually a constant expression. That means the compiler is able to compute the value at compile time, right? Like for example here, if I put 20 plus or 20 times 5, right, the compiler is able to do this computation at compile time. Why is the value evaluated at compile time? Simply because this value does not change. This value will not change throughout our program. Okay, but meanwhile, this line of code, this is referred to as a constant. Okay, this simply means the variable b will not change. Let me explain again more further. There is a relationship between this const int b and this constant expression. Okay, let us look at this our assembly code here and try to understand what is happening. From main, we have an integer which is being created. You can see the highlighted part of this assembly code here. When I hover, you can see the highlighted in I think in blue, in dark blue, right? What is happening here is it is moving 20 in a memory. Okay, then here again you can see this other line of code, it is moving 20 again into memory. Now let us go to where we are printing this constant expression. Okay, one thing you can notice is the compiler, you can see it is printing not from memory, it is just printing 100. Okay, that is 20 times 5. It is not reading from any memory. Please take note of this line of code here. It is not it is not reading from any memory. Now let us go to the macro. Here it has different macro. Like I said from the previous video, macro just simply means copy and paste, right? So you can check the macro evaluation here. Okay, just print f20 instead of printf num. Okay, so before compilation, the preprocessor will replace num with 20. So we can check the line of code here. It is not reading 20 from any memory, so it is just printing f20. But let us go to this line of code and hover it. We can see it is reading from memory, the word pointer. Okay, it is reading from memory and it is printing from memory. Now this is the main difference between a constant and a variable. Okay, so we can see here that in this line of code, this two line of code is just printing the value, not from memory. Okay, but when we come to line 11, we can see we are reading from memory, right? Now let us go to line 13 and see what the compiler is doing. Yeah, again we are still reading from memory. This line is very misleading. Let me explain. Okay, so we have put 20 in a variable b, which will never change throughout our program. Is it required for the compiler to create a variable and store in B? Actually, no, it is not required. Okay, so this line of code is a little bit misleading. Now you can see I'm compiling with our optimization set to 0. So let me set my optimization to 3 and let us look again this line of code. Right, you can see this line of code here. It is just moving 20. It is just printing 20. Our assembly code is now optimized because it is needless for, it is needless for our compiler to really create a variable and store 20, which it will never change. So this value is referred to as constant. Why? Because the value won't change. What if I try to change the value of B? Let's say B should be equals to 5. B equals to 5. What have you noticed? We have a compilation error, right? Compilation failed because the compiler knows the value of B won't change. This means B is being in a read-only area of our memory. So that means the compiler knows the value B won't change throughout our program. So this video is just like an introduction. Okay, there is a lot of stuff that we will see throughout this course. So this is just an introduction. I know some of you might say, okay, I can change the value of B without the compiler giving me any compilation error. So what some of you might do is you might change the value of B using pointer. I know we haven't talked about pointer, right? So but just look at this line of code. I have changed the value of B using a pointer, before I explain to you that it is not possible to change the value of B because B is being stored in a read-only memory, right? So but I have changed it using B. Now this type of behavior is known as undefined behavior in the C standard. So you should never do this. This is just for educational purpose only. You should never do stuff like this. You should not assign a variable as a constant and change the variable using pointer. Though this seems possible, but if you might run this code on your computer and it will fail to compile. Okay, another question is, but what if you want the value of B to be changed in your program, though it is a constant, right? So what will you do? There is another keyword in the C dictionary known as volatile. So you can assign a volatile const int B, and you will notice here, I think this error should go. We still have a warning because the GCC compiler don't like this. But anyway, if you want to change the value of a constant, you can use volatile. Okay, what have you noticed is when I use the keyword volatile, right, you have noticed that on our assembly code we are now using memory. Okay, we are now using RAM, right, and we are assigning and we are using a memory to modify the value of B, which actually it is a bad idea, but when you look at the assembly code, you see why it is possible. We can change the value of B using a point D word into ESI, and we are setting we are moving 5 into J word, which is our RAM. But if I remove the keyword volatile, we don't see any memory which is being used. So this code will likely crash on most of your computer. Though yeah, it seems possible, but this is something very bad. You should not do stuff like this. So in conclusion, it is right to say that in C there is no such thing as constant variable. So reason being, if you print this line of code, right, and you print this line of code, let me comment this line. If you print these two lines of code and you check their assembly output, they are the same. The takeaway of this video is that when you use the const keyword on a variable, right, you are telling the compiler that this variable won't change. So it is needless for for the compiler to store the value of the variable in a memory, because since it knows that the value will never change, so the compiler can treat that variable as a constant expression. So there is no such thing like a constant variable, okay, because you cannot modify a variable marked as const, because the const keyword just say this value won't change. Okay, now so this is just an introductory, and I know I've gone a little bit far for beginners, right? So the reason why I brought this video up is for you to have insights. Like I said, for me, I believe that when you're learning anything, you should learn the basics, you should understand the fundamentals, because any other idea is based on the fundamentals. So that is why I decided to try to show you what is happening under the hood. My name is Mr. CJ. I hope this has been informative to you, and I will see you in the next one.